For centuries, we have seen the world expand faster and faster. This growth cannot continue at this pace in this way. We reach a point where we need to look at what we have achieved and make some modifications. A current challenge engineers are facing is to improve infrastructures that have indeed been aging and failing with time. Let's first explain what is an infrastructure. It is a combination of fundamental systems that support a community, a region, or a country. It could be bridges, roads, schools, public transport, water treatment plants, etc. Now, why is it important to improve them? First, for safety. Second, it is a vital component in the city's economic growth. Infrastructures increase the productivity of a country, therefore boost the economy due to more competition between firms. Also, foreign investors tend to invest more in places with more accessible and developed infrastructures. A good example is the development of China and India. China considerably improved and invested in its infrastructures in the past centuries, which brought that country to become world economic power and leader. In comparison, India didn't base its economy as much on infrastructure development. And today, if we compare these two countries of around as many people, China's GDP per capita is twice as much as India's, proving the importance of improving infrastructures.
Looking at the challenge of infrastructure in engineering, we can identify 4 key fields that are involved in finding solutions to this problem: seismologists, mechanical engineers, civil engineers, and architectural engineers. Seismologists study earth vibrations known as earthquakes, and by studying them, they also try to find more information on how these can have an impact on the surface. Indeed, earthquakes can manifest themselves by longitudinal waves, transversal waves, or oscillations, and each has a different impact on structures. When all fields are working together, seismologists can input specific key information on consequences and impact the earthquakes can have on a structure. On the other hand, civil engineers try to find the best way to render structures harmless or make them robust so limited damage is caused. Civil engineers can also work closely together with mechanical engineers to understand what a specific magnitude means for the strain caused on a structure and how this strain can be lessened by changing the structure of a building. Structural elements that were bearing only vertical loads now also have to carry horizontal bending and shearing effects and risk collapsing if the strain is too high. Being able to have civil engineers and mechanical engineers work together helps detail the structural problem and narrow down the things to change in order to find an effective solution.
Architectural design is an important aspect of building earthquake-resistant design. An excellent architectural seismic design must be completed on the basis of architectural design and structural design working together to consider earthquake-resistant design. In the construction of anti-seismic fortification of the construction quality, improves the anti-seismic fortification, construction quality special inspection, and supervision system. Anti-seismic fortification into the standardized management, only to ensure the quality of construction in order to meet the requirements of anti-seismic fortification of the structure of the house in order to eliminate anti-seismic hidden dangers.
There are many situations where each of these fields can work together to restore and improve urban architecture. An example of this is the flexible bolt, an innovative new design from Cal Poly. In the past, bolts, nuts, and other industrial fasteners have always been rigid. While this usually works fine, in extreme stress situations, the bolts can shear. This new design has the capability to stretch and bend under duress. Resembling a stiff segment of cable, it is composed of different strong, flexible materials, including Kevlar, wire, and steel. This new design can be used to connect surfaces that aren't parallel, for designs that require flexibility, including prosthetics, as well as a way of improving the resistance of buildings to earthquakes. In creating the flexible bolt, there was a necessary collaboration between the different fields of engineering, with materials and mechanical disciplines taking a major role in this development. When the bolt enters the market, architects, doctors, and seismologists will work together with the aforementioned engineers to find the most effective uses for this innovation. There are countless examples where engineers and members of other disciplines can cooperate to help confront the problems we face in urban environments, from the design of wind paths in cities to reduce overheating, to improve fire safety designs that save lives. This relationship is an integral part of solving engineering projects in urban environments.